In this problem, there is a slider and a string is passing over a pulley which can slide over the slider. And this string passes through another pulley and is attached to a block. The block is coming downward with velocity v naught and which is constant. We have to determine the acceleration of this pulley. The solution of this problem has been divided into three parts. In the first part, we will review which concepts are required to solve such problem. The second part consists of determination of velocity of this pulley, that is which pulley is that is sliding over the slider. And in the third part, we are going to determine the acceleration, which is the final problem, and we wish to know its value. So let us start. Here we are going to review the concept used to solve the problem. To solve the problem, first of all, we must know the definitions, how to find velocity and how to find acceleration. In kinematics, velocity is defined as v is equal to dx upon dt, and acceleration is defined as dv upon dt. And I hope most of you know this definition. The second important concept is a string constant. In fact, whenever a string passes over a pulley which is fixed, then the decrease in length of a string on one side equals increase in length on another side of the pulley. This happens because total length of a string is always a constant. So on one side, if length of a string decreases, then on another side, it must increases by the same amount. And this decrease in length and increase in length can be related with the velocity of object attached to a string or connected with a string. The third fundamental concept is the mathematics of a small thing. We must know the meaning of this symbol, this dl. Dl symbol is used to describe very small length. dt is used to describe very small time. And similarly, any d, this dm means a very small mass. A very small part of a quantity can always be represented by the differential symbol. We must remember this thing. And then second thing is the definition of angle. Suppose there are two lines and both the lines have the same length L and they are separated by very small angle. That angle is called d theta. Then the perpendicular distance between these two lines, this distance will be L d theta. That is the length and multiplied by d theta. Remember, this follows directly from the definition of the angle that this straight part behaves very similar to arc of a circle whose center is at the point of intersection and whose radius is equal to L. So this arc length is equal to radius multiplied by angle, and it can be approximated as L d theta. The fourth concept is very, very elementary in nature. In this concept, we are going to just take a review of right angle triangle. In fact, all of a student knows about this, but the application is just opposite. In generally, a student remember that sine theta is equal to p upon h, and cos theta is equal to b upon h. But when we apply it, so most appropriate formula used generally are perpendicular is equal to h into sine theta and base is equal to h into cos theta, isn't it? So if hypotenuse is known and theta is known and you wish to write the value of perpendicular directly, then instead of doing this problem in two steps, we must remember these two formula very carefully so that we can use our mathematics with some speed. So that is all about the fundamental concept which are required to solve the given problem. Now let us move directly to the problem and see what we can do. In this second part of the solution, we are going to determine the velocity of the object. Already velocity of block is given. and a string is attached to pulley which is initially at point M. Suppose the block moves downward by a very small distance, then this pulley move from point M to point N in this duration. And we have denoted these displacements by elementary things, that the displacement of this pulley is equal to dy. And during this duration, when pulley moves from M to N, the length of a string becomes smaller. Initially, the length of a string is AMB. That is this L plus DL, and this L plus DL, that is 12 plus 2DL. And once pulley reached the point N, the length of the string now only remains this distance is L and this distance is L, that is 2L. So as pulley moves up, the length of a string decreases. The length of a string decreases, the length of one string decreases by amount dl, and the length of this string also decreases by amount dl. So total decrease in the length is equal to dl plus dl is equal to 2dl. And hence the length of a string on the another side must increase by amount 2dl. Now you can see that if the displacement of this pulley is dy in a time interval dt, then displacement of the block is 2dl in the same time dt. So we can say that dy upon dt is the velocity of the pulley, and 2dl upon dt is the velocity of the block. Now let us write it carefully. What are the relations? We have found that the velocity of pulley, after our discussion, the velocity of pulley will be equal to dy upon dt. And we name it uh, or we symbolize it using a symbol b. And at the same time, velocity of block, you have seen, it has been given that the block will move down by a distance 2dl. So this is equal to 2dl upon dt, and it is given by v naught. Okay. Now let us find relation between v and v naught. If we can relate y and dl, then we will be able to find the relation between v and v naught. So we have to understand the geometry of the situation. Okay, see here you can see that this length is equal to L. This angle is equal to theta. This distance is given equal to B. This distance is also given equal to B. This is a right angle triangle, and in this right angle triangle, the perpendicular and base, that is this B and this B, both are same, and the string length is equal to L. So what things we can find using this geometry? We can find that theta is equal to 45 degree because the triangle is isosceles triangle. And secondly, we can find L is equal to under root b square plus b square, that is equal to root 2b. Okay. And now come to the third part. Third part is the relation between dy and dl. To relate dy and dl, focus yourself on this part of the diagram, this part, this part, that is that I am highlighting. In this part, you can see that this distance is equal to dl, and this distance is equal to dy, and this ds is a perpendicular between this L and this L. This is a right angle triangle. This is a right angle triangle. What we have done, we have considered this point as a center and have constructed an arc of radius L and this angle d theta. So this ds is the arc length, and this ds can also be written as L into d theta, and this ds will be perpendicular to the length of the string. So we have also other relationships. These relations we can say ds. ds is equal to L d theta. Okay. And also ds is perpendicular length. Now you see this is a right angle triangle. In this right angle triangle, this angle is 90 degree. The side opposite to 90 degree is known as hypotenuse and its length is dy. We know the theta. For this theta, ds is perpendicular and dl is base. So using the shortcut, if base is hypotenuse times cos theta and perpendicular is hypotenuse times sine theta, we find other relationships also. These relationships are ds. ds is dy and multiplied by sine theta, and dl is dy multiplied by cos theta. dy multiplied by cos theta. Okay. Now we are going to use this dl in this relation. Let us name some relations. This relation is 1, this relation is 2, this relation is 3, this relation is 4, this one is 5. So we have in total 5 geometrical relationships using this diagram. Now we are in the process of solving. We will use 5 in 2. So using 5 and 2, what we are going to get is 2 into dy into cos theta upon dt is equal to v naught. Okay. But from 1, you know dy upon dt is v. So using 1, you are going to get a very simple relationship. 2 and in place of dy upon dt, we are going to write v into cos theta and this is equal to v naught. Okay, so now this is time to find the value of acceleration. We have found the relation v is equal to v naught upon 2 cos theta and 1 upon cos theta you know is equal to sec theta. So this can be written as v naught upon 2 sec theta. Okay, now we are going to use the kinematical relation that acceleration is dv upon dt, isn't it? So we are going to differentiate our velocity with respect to time, and velocity is v naught upon 2 sec theta. Before differentiation, you must note that here we are going to differentiate sec theta with respect to t. So this is directly not possible. What we will have to do is to change the respect variable. We are going to differentiate sec theta with d theta, d upon d theta, and then multiply this d theta with the remaining dt, isn't it? And now this acceleration will be given as v naught upon 2 and the differentiation of sec theta is equal to sec theta into tan theta. Okay. And the next term in our preparation is d theta upon dt. Yes. Now we are very near to the solution. D theta upon dt is the only constraint. So we are going to find d theta upon dt. If you could remember from the previous solution that we already have relation ds is equal to ld theta and also ds is equal to dy into sine theta. So using this relation we can find d theta upon dt. Differentiate both side by dt. This will give you L into d theta upon dt is equal to dy upon dt into sine theta, isn't it? But we know dy upon dt is nothing but v. So this is v sine theta. Clearly, you can see that d theta upon dt is v sine theta upon L. Okay. So our acceleration is now given as v naught upon 2 into sec theta into tan theta multiplied by d theta upon dt, and this d theta upon dt is nothing but v sine theta divided by L, isn't it? Also, we know this V is nothing but V naught by 2 sec theta. So we should put this value here also, V naught by 2 sec theta into tan theta and multiplied by V naught by 2 sec theta into sin theta upon L, sin theta upon L. Now finally, we can write our acceleration as v naught square upon 4L. Yeah. And sec theta into sec theta is sec square theta and tan theta into sin theta. Tan theta multiplied by sin theta. Now, from the geometry, as we have already seen, that theta is equal to 45 degree. And if theta is 45 degree, then we know tan theta is equal to 1. We also know sec theta is equal to root 2. We also know sine theta is equal to 1 by root 2. And at the same time, we have also determined the value of L. L was equal to b root 2. Substituting all the values, we are going to get our acceleration as v naught square upon 4b. This is our solution. Of course, this is advanced level problem and it has a long solution. But once you solve such question, your thinking, your logic will develop at the advanced level. Hope you understand the solution. Thank you very much.